All right, guys. So, we did so much with our notes on the first day. A little half a page there. So we're going to jump in and do a lot more today. We're going to talk about classifying your data. Like, what are you collecting? So there's two types of information you can collect. The first is quantitative. Okay, quantitative is a numerical value. And you can ask yourself, should I take the average of this type of data? If taking the average makes sense, it's probably quantitative data. So I would say taking the average makes sense. Kind of have that already right here. Okay. Some examples. Time is quantitative. Distance. Height. So sometimes you can think of it as something that you can measure as well. That's another way to look at it. Okay. All right, then we have categorical. It's what it sounds like. You can put it into a category. All right. Your answer to your question is usually a word, not a number. Now, we say usually there because numbers can still be categorical if you're just using them as like a ranking type system or something, categorizing your feelings, anything like that. It could be a number, but averaging them wouldn't make sense. Okay. Can you guys think of any examples of a categorical data or variable? Colors, yeah. No categorical variables today. We're going to go through some examples with a bunch of different ones, but color works with a lot of different things. You can have hair color, eye color. We can separate you into clothing. We can do gender. We can do all sorts of different categories. Okay. All right. And these are always used to calculate a proportion. So your proportion, that's the number of successes over the sample size. Usually X is going to represent our number of successes, and then do you remember what variable we use for sample size? Lowercase n, good. You could think of categories also as like class periods. There's, a 5th period AP stat, and there's a 7th period AP stat. 5 and 7 are numbers, but does it make sense to average those? No, okay, I'm just separating you into categories. All right? Not too bad so far, right? Okay, we've got some variables to fill in next. So we've got a lot of symbols that we use in statistics. So first, parameter, remember, we're talking about the population. And then statistic, we're talking about your sample. So just one more review of that population. We were always capital N, sample size was lowercase n, right? Okay. So then within these, we can talk about mean, standard deviation, variance, and then we can also look at our proportion for our categorical variables. So mean. Do you guys remember what a mean is? Average, okay. If we're talking average of the population, our parameter, you use a Greek letter, and it's mu. If you're looking at just the statistic from the sample, it's called X bar. It's just X with a line over it. All right, your standard deviation. You see a sigma. That's a parameter coming from your population. You just see an S. We're talking about a statistic from your sample. And you'll see all of these on your calculator when we'll put in data values and calculate 5-number summaries, all that stuff. So, all right, then variance, all that is your standard deviation squared. So variance is sigma squared or S squared. And we'll talk more about what variance means later. Okay, then if we're looking at a proportion for a parameter, it's a capital P. For a statistic, it's a lowercase p with a hat on it, so we'll call that p hat. Yes, you have to recognize what these symbols are. I don't even want to say you have to memorize them. You're just going to use them so much that they become second nature to you, okay? So let's try a little. So go ahead, turn the page. First little bit of practice here. I want you to just partner up with somebody sitting next to you, work on this, look through your data that you're given, and then try to answer these questions down below. Let's do we'll go through them one at a time here. So just do the one with the big table at the top to begin with. So example 1. We'll go over that, and then I'll have you keep working. Be specific when you're answering these questions, okay? guys, how many of your parents are going to West back to school next? Some of you are like, yeah. Maybe.
I thought it was always been 2 or 3 weeks into school.
Lots of years they've been doing it very first week of school. It's good and bad. Yeah. So I feel so bad because parents all the time. Like, here I know a decent number of names for my other classes. I know, yeah, this week's a little not in a good rhythm yet. We'll get there. All right, guys, how you doing on the first question? Good. Okay, let's go through it. All right, population of interest. This is where I want you to be pretty specific. Anybody think they got a good one?
U.S. residents and Mexican taxes.
Okay, that works. Yep. I wrote down all U.S. residents in the year 2000, but yours is fine too. You just want to be careful. You don't want to say just U.S. residents. Okay, that's not specific enough. When everyone in the U.S., what are we talking about here? So you're going to use the word all a lot when you're talking about population of interest. Okay? So we're good with that one? All right, so let's go through. I'm going to write them up above because I don't have room to squeeze everything in there. So state, what do you think? Is that categorical or quantitative? Qualitative. Put a C, it is qualitative. That's another word for categorical. What about number of family members? Okay, and then I think I asked you units, so what'd you say for that? Like number? I mean, there's not really a good unit for that one. All right, age. Okay. Years, right? What about marital status? Categorical. Okay, you're thrown into a category. You're married, never married, single, or separated. Total income, what do you think? Okay, and I'm just going to say money. Okay, travel time to work. That is quantitative, and we're measuring it in minutes, right? Okay. So far, so good. Okay, let's move on to the next one. All right, so you've got a car company here. Go ahead and try this one.
So which one? The problem. The 30,000.
Yeah.
Yeah. What's the problem?
Are we ready, guys? All right, so population being studied. I would say all cars in this line, because we're talking about a new line of cars, right?
So I put population being studied as the upcoming line of cars.
That works, yeah.
Just putting cars, however, is not specific.
Yeah, just cars would not be enough. Yep, you're exactly right. Okay, and then there's two variables being studied. What are they? Yeah.
There's like the average miles per gallon.
Okay, so we'll just say miles per gallon, and that is,
Quantitative.
yep.
But you just kind of measure it in miles per gallon.
Yeah, it is what you measure now, yes. What's the other variable, guys?
Whether or not it had mechanical problems in the first 30,000 miles.
Yes, so that's really fun for me to squeeze in here. Whether or not as a mechanical, I'm abbreviating. First 30,000 miles. So what kind of variable is that, guys? Yes, because that's, it does or it doesn't, right? You're putting it in those two categories. It's a yes or a no kind of thing. Okay. And then identify any important values and use the right statistical symbol. So what are you going to tell me?
N equals 2. Oh, N equals 35.
Okay, your sample size is 35. That is good. What else? What is the 65.5? That is X bar. Excellent. Okay, and what about 11%? Some of you have it, I know. I thought I forget. P hat.
Oh.
Because it's of your sample, yeah, and that's the tricky part is, you know, noting which one it is. So your P hat is 11%. And you're just going to say 0.11 for that? Okay. All right. Questions so far? So those are both statistics, not parameters. All right, try the third one for me. Very good. Got to throw in that little
What is the population in study?
Great questioning. See how you can overthink like what the population is or what, yeah. So, practicing. All right, so population in this one, I would say all students in this district or all students in this county, which we're talking about here. I think district is what we're looking at. How do we do on that? Yeah, okay. Don't just say students. Okay, that's not specific enough. So all students in this district. Okay, variables. What do you think? What's one variable? Score on this test, right? And what kind of variable is this? Are there any other variables? No, all we're looking at is the score that they're getting on this test, okay? But then we can talk about a lot of different values from this. So, what is, well, just give me some of them. What do you guys have? What do you got? N is 200, I like that. David, you got one? Yep. All right, what else? Yes, no. Mu is 428, yes. What else? S equals 12, good. All right, that's all I have for that one. We're okay with that? So, paying attention, is this a statistic? Is it a parameter? What are we looking at here, okay? All right, well, let's keep moving. We get to construct our graphical displays of data. Now, some of this is going to seem simple. You'll be like, I've been making pie charts since what, like third grade? I don't know when you first start making those. You have to be very specific with your labeling. You can get some pretty easy points on the AP test by drawing your graphical display correctly. But don't make silly mistakes. Don't leave off units. Don't leave off a title. Don't forget to label an axis, that sort of thing. Okay, so this isn't super hard, but it is something that you need to pay attention to the details. All right. So again, the context, that is super important. You need to make sure you label everything. All right. Scale, you need to make it look right. You can't just go from 0 to 100 as one tick mark, and then every tick mark after that is 10. Okay, you can show gaps in the spacing on your axis, but you have to actually denote that. Make sure there's a title. So let's just make a quick little graphical display.
Oh, also, don't forget to jump from 0. Like, you can't. So if you have a graph that starts from like, for Donald Trump's approval rating, say, if you had a graph that starts at like 38 and tops out at 42, you could say like, and a poll stated that Trump's approval rating was 41% last time to 39 this time. You could project that Trump's approval rating had fallen immensely, even though it was barely like noise.
Okay, yes. Yes, definitely make sure you note the jump from 0. Okay, so we want to make a little graphical display here of these 5 test scores, okay? Clearly I've just made up some data for you, but that's okay. All right, so I'm going to make a histogram. What do you think I should put where? Any ideas? Score, I'm going to put that on the bottom. Most of the scores are what, between 70 and 100? Okay, so I'm going to show that there's a little gap from 0, and then I'm going to put my first tick mark at 70. And that's all you have to do is show some little, you can do 2 lines. Sometimes you'll see like a squiggle, almost like, you know, a heart rate monitor. That's what it looks like a little bit there. And then since we're doing a histogram, the vertical axis is basically going to be your counts. So we're talking about students. I'm going to say number of students. So between 70 and 80, how many test scores fell in there? 1. So I make a little 1. What about between 80 and 90? 2. Between 90 and 100? Also 2, right? What's my graphical display missing?
Shading.
Shading, I could shade those in, yes, crucial. And someone said title, it's even more important. Yeah, what do you want to call this?
Students who scored in between each range.
You can just say stat test scores, or
All right.
that's all you have to do, okay?
I got a pretty even distribution.
We will start describing our distributions soon. Okay, so that's just a very simple histogram. We're going to go through different types of graphical displays. There is a difference between a histogram and a bar chart, like a bar graph. Those you've been doing for quite a while. All right, the next one we're going to talk about is quantitative. For quantitative data is the frequency table. So again, we are only looking at quantitative data to start with here. So we're going to put some values in this chart. We're looking at age. And you kept the little sort of subsets. I'm going to give you 20 to 30, 30 to 40, 40 to 50, 50 to 60, and then I know there's not we're making an extra row, okay? We're doing 60 to 70. We're going to do the frequency. We're going to do the cumulative frequency. What does cumulative mean? You have a cumulative test. What does that mean? All of it together, right? So if it's cumulative frequency, it's like you're working your way down the chart and they're all getting added together. You're compiling all of the frequencies as you go. So cumulative frequency. We're also going to do relative frequency. And then cumulative relative frequency, okay? Okay, so when you see the age here, 20 to 30, 30 to 40, 40 to 50, well, 30's here and 30's here, 40's here and 40's here. Like, what, do you guys know which one it actually goes in? Guess. Always it's 20 less than or equal to X less than 30. So it's the lower number that is included, okay? You don't have to write them all in, it's up to you. And technically the 70 could be less than or equal to because we don't have another group that it could fall into. All right, so what I want you to do is go back to the census data that we had, and I want you to figure out the frequency for each of these, okay? So how many 20 to 30-year-olds were there? 20 to 30, how many were in there? 4. 30 to 40.
3,
40 to 50.
2,
50 to 60.
0.
0.
And 60 to 70.
1.
Okay. That's good. You guys can count. Good work today. All right. Cumulative frequency. So you start with the first group here. There's 4. What do you think the next one's going to be? 7. Next one.
9.
Next one.
9.
And then 10. Okay, you're trying to get to the total number that we were looking at. Then relative frequency is just talking about a proportion of the whole group. So 4 of the 10 were in this first age subgroup. Okay. 3 out of 10 were from 30 to 40. 2 out of 10, 40 to 50. You can say 0 out of 10 or just 0 for the next one. Doesn't matter. And then 1 out of 10. So it's very easy to see the percentages within each subgroup of the ages. Okay. What do you think cumulative relative frequency is going to do then? Cumulative relative frequency. Yeah, so you start with 4 out of 10. What do you think the next one's going to be? 7 out of 10. 9 out of 10. Still 9 out of 10. And then 10 out of 10. Every time that last box should be reduces to 1. If you have a different number in your numerator and denominator, something went wrong with your counting somewhere. Okay.
Does it have to be a fraction or could it be a percentage?
You can do either. Yep. Okay. So this gives you an easy way to say, okay, 70% of the people in our sample were below 40 years.
This is why quantitative data doesn't work for cartographic data, since categoric data, since you can't really scale like married, unmarried.
Exactly. Yep. Yeah. So frequency tables only for quantitative data. Okay. Make sense? Okay. Let's keep going. All right. A histogram. We sort of made a pretend one with your stat scores there.
So, I'm sorry, I like graphed the number of Virginians over time, just as an example.
Histogram has to be solved. Okay.
All right.
Okay, sorry about that. All right, so I want you to make a histogram out of the age data that we just looked at. Okay, ready to go.
We don't have a time factor though, so what are we going to use this for?
Histogram doesn't have anything to do with time. Remember, this was like this is an example of a histogram. Becca, you want to look up here for a sec? That's a histogram.
All right.
It's like counting within subgroups.
People.
Yep. Just a note, not the same as a bar graph, okay? Okay. All right, guys, what am I missing? Title, okay? So I've shown the gap from 0 here, because these are not equally spaced. I've labeled this, we're talking about ages. These are our counts for the number of people within these different age groups. Your title, I saw a lot of different titles, which most of them were fine. I would say something like ages, U.S. residents. You could even say sampled,
Like,
from the 2000 census. Okay.
if you just said ages of U.S. residents, then we'd be mighty suspicious about the
Yeah, there's
Every
no one in the
0.
U.S.
Yeah.
between the age of 50 and 60. Yeah, that would make a lot of sense. Okay. So just be specific with how you label it. Like, don't just say ages. Okay, that's not enough. All right.
What if you didn't say sampled from the U.S. or the 2000 census?
What did you say?
The ages of U.S. residents in the 2000 census.
I would include, yeah, the sample, just because this is a very small data set and it doesn't represent the actual census. So, yes.
What age of surveyed U.S. residents be?
Yeah, I would include something about the sample in it. Okay. Yep. Okay. So we okay with that? Not that hard to create. It looked like walking around. Everyone did a good job. Your bars touched each other in a histogram. In an actual bar graph, there are spaces between the bars. Okay. So everybody looked like they did that right. Okay. Next is a box plot or a parallel box plot. We're still talking quantitative variables here. Do you guys remember these from long ago? Pretty long ago for you guys. Okay. Do you remember what's represented in each of these? Like how much of the data is in this little whisker?
No.
25% of your data is in this first little group, 25% in this half of the box. It's not really half the box, but 25% for this side, 25% for this side. So it shows you the shape of your data, that these values are much more spread out than these values. Okay? Because if there were 12 values in your data set, 3 of them are up here, 3 of them are in here, 3 of them fall within there. Okay? It splits your data evenly into 4 groups. So it can show you like they're evenly spaced, they're not evenly spaced. We might have an outlier in this group. So you can kind of get an idea of what's going on with your data. One of the negatives is you can't see your individual data values anymore. You have no idea what those numbers were. You just know that 25% of them fall from here to here. Do you remember what this is called? It is a box and whisker plot. What about this? Like, what would this number be that's represented by the end? There's some Q stuff going on. This is just your minimum. What is this one? Okay, good. We also have quartiles. Yeah, your quartiles. I think it's actually on your next page. Is the 5-number summary. If you turn the page, it talks about that. It's at the top. You copy very well. You've got your minimum. That's the first thing shown. Then there's the Q1, the first quartile. Okay. Then our median, Q3, and your maximum. So I'm going to draw a sideways one down here just to reference those values for you. So this is your min. That's your Q1. Median. Q3. And your maximum out there. They can be horizontal, they can be vertical. It doesn't matter with your black spots. If you have to create one, again, the labeling is super important. You can see everything's been labeled for you on this one so that you can understand what you're talking about with your data. All right, let's keep going. Stem and leaf plots. So there's a few different kinds. This is a just regular stem and leaf plot. This is what's called a double stem and leaf plot. This one happens to be a back-to-back and double. We should include that at the top there. Double stem and leaf plot. So let's look at these and how you read the values from them. So they give you this little key here. It says 2 with your line 2 represents 22 pairs of shoes. So I know that a 1 over here and a 0 is representing 10, the number 10. So this would be the number 4, 5, 5, 5, 6, 7, 7, 7, 7, 8, 10, 10, 10, 10, 11, 12, 14, 35, 38. Does that make sense? So if you wanted to, you could list all the individual values. You can see all of the actual numbers from your data set. The double stem and leaf, what do you think is different here? Why do you think it's called a double? Yeah, so instead of 0 here and then listing out all of these, it's broken like 0 through 4 would be in the first group, your 5 through 9 would be in this. So 10 through 14 here, 15 through 19 would have been here. There are no numbers 15 through 19. Does that make sense? Okay. 22, nothing above 24 until we get to 35, 38. Okay? The back-to-back that happens to be a double in this case as well. You're doing the exact same thing as that, but you can work on one side for the males in our group and then the other side for the females. So like this would represent the number 24 for a female, okay? You just have to, tell your brain to read backwards for a little while. You can do that. Does that make sense how you read these? Okay. They sound trickier than they are. With these, again, it's nice to see you have a good idea of where your data values are kind of clustered, if there's any big gaps or anything going on with the data. We're going to keep talking about describing your data. We're going to get very specific with that later. So, all right, a dot plot is our next one. So these are very simple, but it's also very easy to create, very easy to see what's happening. We know that survey the number of siblings. You know, there are 3 people who have 0 siblings. You can just count your dots. This is how many people have 1 sibling. Okay, so it's kind of like a simple version of a histogram. You're just putting dots instead of making the actual columns there. Okay, all still quantitative data that we're looking at. All right, questions so far? A time series graph. So with this, your x-axis is always time.
Thus, I don't think we can use our census data graph here since it all takes place at once, right?
Right, yeah, I don't have, there's nothing from that you can create a time series graph of it. That is correct. It looks a lot like a scatter plot and like a regression with a line of best fit. It's not technically that because your x-axis can never change. In a scatter plot, your x-axis could represent anything. Here, the x-axis has to be time. So what we're looking at here is distance. We don't know what distance traveled when, but distance traveled over a certain number of weeks. And so you can see, you can look how far did they travel in the 11th week. How far did they travel in the 17th week? So you can see a trend. Whatever this is representing, the distance is definitely increasing over time. You guys see it's got like a positive trend. You'll see things that look a lot like this oftentimes with financial data. You know, you'll see how the market's doing. Is it growing? You know, and there's a lot of little ups and downs in the short term, but you're looking at over time what is happening with that set of data. Okay. All right. And then we have the cumulative relative frequency graph, or the ogive. It's just kind of fun to say. Ogive. It's not an ogive, okay? It's an ogive. All right, you can identify percentiles with this. So what I'm talking about with that, if I look at the 15-minute call length here, if I go ahead, I'm looking at that one. If I go over to the left, it looks about like 40, right? It's close. Okay. What that means is that about 40% of the calls are 15 minutes or less in length, okay? So it's not saying that 40% of them are exactly 15 minutes long. This is cumulative. You can see it's adding it up over time until we get to 100% of our data. So if you're looking at this, you know, when you get to the 10-minute mark, it's 10 minute and everything less than that. Does that make sense that we're adding it up? You could also look, if I wanted to go between like 15 and 20 minutes. Can we call that 60? So I could say 20% of the calls are between 15 and 20 minutes in length. Does that make sense? But 60% of them are 20 minutes or less. Okay.
Wait, so between the 60% goes to 30 minutes, or wherever the example is on the physical screen?
So it's just how it's a little uphill line, so that no, we're not perfect. Does it make sense what I'm saying with it over there?
40% of the calls were ended by 15 minutes, and for 15 minutes or fewer.
Are we okay with this, guys? Does that make sense what we're talking about? All right, we'll stop there. Lunch is coming. We are looking at categorical data now. Go ahead, flip the page. All right, so the first one here, that is a bar graph. Do you guys see how it's different than a histogram? Does that make sense? And across the bottom, you can't just label the x-axis one thing. You've got your different categories that are labeled there for each. So we're comparing US and Europe, so that's why these actually touch. But then you see there's a gap when you get to the next category. Okay, so gaps if you're doing a bar graph. And then we can also use a pie chart. Okay, so it's just you've got your different categories and the percentage of the pie that it takes up is the percentage that that category is. So what I want you to try to do is to just next to each of these, you're going to make. Bless you. Oh, goodness. You allergic to categorical data?
I guess.
All right, so you're going to make one of each of these for marital status from our info, our census info that we had, okay? Because that was a categorical variable for us, right? Do you know what I mean? I want you to make a bar graph and I want you to make a pie chart. Does that make sense? Okay. They'll be fairly simple because there's not a lot of categories and not a lot of categories within marital status and not a lot of people either. You're really looking at 10. Okay.
Just like in general, like, would you ever make a photograph for one species?
Nope. So specifically, these only work with categorical. And the ones we were doing before, like you couldn't do you can't make a time series graph for categorical. Okay, so it is specific which one you do. So I'll give you a little time here. Try and draw those. What do you think? Do we need labels for these too?
Sorry, I these.
Okay, so we're on this section. So you're going to make some bar graph, and you're going to make a pie chart.
Okay.
Okay, does that make sense? Everybody good with what we're doing? We're like that. The marital status from it's okay if you can't draw a perfect circle, don't do it. How many different groups within marital status are we going to have?
3.
3, okay, good. you are making your bar graph, guys, look at this one. What does it say over here on the left? Percent. I would suggest you do percent for that, not counts like you did in history class. Okay? So if you're making your bar for Mary, you're going to have 70% in that. That makes sense? So just change the way you labeled it. If you did counts instead of percent. That lends itself nicely to your pie chart. Then you should see 70% of the pie taken up by Mary, only 10% of the pie separated. Just quick. Here. Working around, it looks like you guys are doing a good job of putting a title on each of these, labeling your categories on there. Yeah, you're doing the same thing, just with yep. Okay. All right, guys, so I think everyone's okay with drawing those. It's not real common that you're going to have to make like a pie chart on an AP question, but you will have to read a lot of them. So, all right. Just do a little bit. All right, so we're going to start looking at describing the distribution of our quantitative data. So you'll hear me say over and over and over and over and over, did you do the cuts? Did you explain all of those? So C stands for center. U is unusual features. That in. That says features, okay. All right, one of your S's is shape. And the other one is spread.
Shape spread.
If I ever asked you to describe a distribution, you must say all four of these. If there's no unusual features, just say no unusual features. You don't ever skip any of these, okay? You just describe exactly what's there. So with our center, there's a couple different types. Of central tendency, what we talk about when we're doing center. The first is your mean. So remember, X bar is if we have a sample mean. Mu is if we're doing from a population. what is the mean? I think you guys all know what the mean is. Average, yeah. All right, another type of mean is the weighted mean. I think you guys are familiar with this, with calculating your grades. You know, understanding like you do your final grade, that each quarter is like 22.5% and the final exam is 10%. At the end of the year, kids are always asking me, what do I need to get on my final? So you're going to do a little algebra there. So I want you to read through this and see if you can figure out what the weighted average is or weighted mean is for this kid's grade, and will they get an A? So take a second here. You can use your calculator to do this, okay? This looks a little more confusing. This is just saying the summation of each weight times the score. So you're adding all of those together and then dividing by the total number of weights, which is usually going to be 1. Give you guys a minute here. You guys, you can share a calculator if you need to today. It's not the end of the world if you don't have one. But do start getting in the habit of bringing your calculator with you every day, okay? You will use it a lot.
No.
So guys, what are you doing to calculate this? How do you find the weighted mean? Midterm scores 83, final exam 95, 40% and 60% of the weights. What did you do?
I did 0.83 times 40, and then I did 0.95 times 16 and add them together.
Okay, what did you get?
Oh, I don't have my calculator.
Have your calculator? Okay. Second?
I actually did a calculation of this by hand. I multiplied 95 by 3 and 83 by 2, added them up, and then divided by 2. So I got 90.2, so you will get an A by a hair.
That is perfect. That is absolutely one way to do that. If you're 60%, that's like there's 3 of them getting to your 100. The other way to do it, so my brain like can't function right now if your way would work. I just did 40% is 0.4 times your score of 83. I think you thought of the quarters as the percents instead of the, you know what I mean, instead of the breakdown of the weighting.
Oh,
Man, getting grades, it makes you feel smart, doesn't it?
So I would do 0.4 times the 83, add to it 0.6 times the 95. You're dividing by 1 here, because 0.6 plus 0.4 is 1, and you do get the 90.2, so yes, you get the A. How do we do? We didn't have a calculator. I know you didn't, most of you didn't actually multiply that out, but are we okay? Yes. Okay, just pay attention to what is the weight and what is the score. All right. Okay. Outliers. So you guys learned about outliers a little bit. Oh, actually, let's talk about median and mode first. So what is the median? The middle number. So
Or an average of the two middle numbers if they're an even number of results.
okay, so if I say 2, 12, 3, 6, and 5. Is 3 the median? No. Wait. 5 would be the middle number, right? Okay. So it's not just the middle number, it's the middle number of what? Yeah, so the middle number of an ordered list. So just be, again, we have to be very specific. Middle number of an ordered list. So Rebecca, you are right. You can average if there's an even number. All right, mode. Most frequent number. Yeah, order doesn't matter there. Yes.
So outliers are basically objects or results that are way out of the mean, way like far different than the other results. Thus, which can so an outlier can by itself skew data unfairly. So suppose we're surveying the net worth of people of Madison Drive. 5 of them are worth $20,000, while one of them, now we surveyed 10 people, 9 of them are worth $20,000, but one of them happens to be a billionaire and is worth $1 million. Thus, if we were using the mean, you could say that the average net worth of Madison Drive is 100 million, but that would betray the fact that most of the people are actually nowhere near that wealthy.
Definitely. So he's exactly right with what he's saying. If you have an outlier, it can skew your mean much more than it's going to skew your median or your mode. Okay, when you're calculating the average, if you have one number that's significantly different than the other values in your data set, it's going to pull your mean either up to that, or if it's a lower number, an outlier on the left side, then it's going to pull it down. So we'll talk about skewing distributions. We'll get into that a little bit. But the mean definitely can impact that, and that's what we were talking about. The mean is less resistant to outliers. That just means an outlier is going to have an impact on the mean. Median doesn't really matter because you're putting them in order and then finding the middle number. So if this last number is significantly larger, it's not going to impact the median. Mode, you're just looking for what occurs most frequently. So one outlier is not going to change your mode. Okay, so you just something to be aware of when you are talking about describing the center of your distribution. Okay. All right, guys, that is where we are stopping with our notes today. So we're making